Okay, so in section 5.6 and 5.7, they're pretty much the same thing. They're talking about scatter plots. And a scatter plot is when we want to go and collect some data. Not every situation fits a nice straight line or a nice curved line. That's why it's called a scatter plot. They might make a trend in the data, like it might be looking like it's going toward a straight line, but it might not be exactly a straight line. So that's why it's called a scatter plot. We're just going and collecting data. We're comparing somebody's age to their weight or things like that. Okay, so scatter plots is used in a lot of different situations. The medical field collects a lot of data. Businesses collect a lot of raw data like this. And then you have companies that hire statisticians that kind of try to compare the data. I have a friend who is a statistician for diabetes research. And he lives in Murfreesboro. He's had diabetes his whole life. He went and got a math degree, and now he's a statistician working out of Nashville for a diabetes research company, which is really cool. But he collects data, and he looks for trends in data all the time. So it's used to find if there's a relationship between data. So there's three major types of correlation a scatter plot can have. We got a positive correlation, a negative correlation, or no correlation. Now, a positive correlation would be looking like the trend in data is going up from left to right, just like a positive slope. It looks like it's going up from left to right. So we might start over here, my low x's, and the higher the x's go, the higher my y's go. That's called a positive correlation. So it goes up left to right like a positive slope. Negative correlation, things start to go down from left to right. And we have no correlation when we can't really tell if it's going to be positive or negative. If it's kind of all over the place, scattered, we can't really say it's a positive or a negative correlation, then we call that no correlation. So does that make sense for all three of those? Positive goes up, negative goes down. All over the place is no correlation. Yes, sir.
What if you end up having like 2 outliers? Can you throw that off?
Outliers can throw your correlation off. Yes. But if you just have like one outlier, kind of ignore it. Because outliers do happen. They do. Big time. All right. So this one's pretty simple. They give us data, and that's our x and y coordinates. That's our data. All right. And we want to make a scatter plot and describe the correlation. How do you think you make a scatter plot? You just graph the points. That's it. And they did these on a horizontal table. So just graph all of those points. So down 2 up 4, or left 2 up 4. 2, 2, 1. And when you graph your 6 points, look up and see if your points are in the same place as mine are. Might help you guys if I make my lines darker, so I'm going to do that real quick. That's a little better. All right, does everybody have your points graphed? So, do you think this scatter plot has a positive correlation, negative correlation, or no correlation? Negative correlation. Why negative? Yeah, the trend in the data from left to right, it looks like it's going in a downward direction. So, we would say this one has a negative correlation. And that's all this one asked us to do, right? Make the scatter plot, which means plot your points, and then describe the trend in the data or the correlation. Sound good? But they're not all going to be that way. No. All right. Let's talk about a line of fit. Line of fit. A line of fit. Now, we have scatter plots. That means our points are scattered. Okay? When we put a line through our data, it's not connect the dots. Remember when you did connect the dot little drawings when you were growing up and you'd go from 1 to 2 to 3 to 4 to 5 to 6 to 7. And you'd make some picture or whatever, Mickey Mouse or whatever. All right? Lines of fits are not connect the dots because that would be really jagged on a scatter plot. A line of fit is a straight line. Okay? And so when you draw a line of fit, you want it to go through the middle of your data and you want to get it to touch or at least be close to touching as many points as you can. So we want to try to get as close to the middle of our data as we can, or if they're really close together, try to touch as many with a straight line, not a jagged line. You don't have to write these directions for problem B if you don't want to. So what we're going to do now is we're going to make a scatter plot. And then we're going to draw a line of fit through the scatter plot. And then we're going to write an equation for our line. Okay? So they've given us this data. The first thing we're going to do is plot all the points. Now these little 0.5 things are halfway, right? So that's 0.5, negative 1.5. So that means I go to the right half and down 1.5. So I'm about right there in the center of that square. 1.5 plus 1. So if you have fractions or decimals with your ordered pairs, just kind of estimate where they are. And then you're going to draw a straight line. I'll do mine in blue. And you want it to go through your data. And you want to touch or be really close to touching as many points as possible. That will not work. Arrows on it. And that is your line of fit. Now, what kind of correlation does this data have? A positive. So our line that we drew should have a positive slope. Okay. All right. So the last thing we have to do is write the equation for the line. And we're going to put it back in slope-intercept form. We're going to do y equals mx plus b. It's just the easier thing. So what two things do you need when you're writing an equation in slope-intercept form? Slope and y-intercept. Okay, look at your points and see if you have a y-intercept. You actually have two of them, right? Right? Pick one. Yeah, mine's going down through -4. So you can pick either one of those. B equals -3 or -4. Whichever one you want to pick. Whichever one is your friend today. Then what you want to do is pick 2 points from your table. Okay? Now, if you have one of them that's kind of like out there, say we have one of those outlier ones over here. I don't want to pick the outlier point. Okay? Pick 2 points that are close to your line, but are not close to each other. For example, if I pick these 2 points, that's going to give me a vertical line. Is this a vertical line? No, so don't pick 2 points right beside each other. So I might pick this one and this one. Okay? So pick 2 ordered pairs, not close to each other. And then you're going to get your slope. So pick any 2 points that are not an outlier and not beside each other and get your slope. So the y2 is 3, right? If you need to rewrite them so that you can tell, by all means do that. So that's going to be 3 minus -3 over 2 minus 0. Well, that makes 6 over 2, which is what? 3. Now, if you pick 2 other points, you're not going to get the same slope as 3. You might get a 2.75, or you might get a 3.3. Okay? But they're all going to be close to 3. Does that make sense? Your slope's going to be different from somebody else's if you pick 2 different points, but they should be close. Does that make sense? They should be close. Like I shouldn't get 3 and somebody get a half. You know what I'm saying? Yeah, 10 would be completely different too. You know what I'm saying? They should be really close. So I've got an m and a b, don't I? Write your equation. Y equals 3x minus 4. And again, if we have a positive correlation, our slope needs to be positive. Right? So that's a quick way you can check yourself on your slope, especially. Positive correlation, slope needs to be positive. And that's really all of it and the most difficult as it's going to get. Plot your points, draw a line, look for a y-intercept. If they don't have a y-intercept, you know what you can do? You can estimate where your line went through. Okay? You can estimate. Because these are lines of fit, not lines of best fit. And then you pick 2 points that are not outliers and not right beside each other and get your slope. Okay? Well, I would say -0.5. I would say -0.5. Yeah. Well, I would estimate the fraction it is. Yeah, I would estimate. All right, let's try another one. Now this one, notice that all the points are positive. All the x's and y's are positive, and they go all the way up to 14. So what did I do with my graph? I went by 2's, didn't I? On the y-axis. Now I kept my x-axis going by 1's. So whatever you want to do there. Just if you're going to go by something other than 1, you need to label it for me, okay? So graph those points and then go ahead and put a line of fit. Yes, if you're confident in yourself, go ahead and do it. Because we're going to do those on our own. I'm just going to graph real quick. So 1, 3. About right there. 2, 5. So those odd numbers, if you're going up the Y's, you need to make sure you're going halfway. 3, 8. 4, 9. 5, 11. 6, 12. 8, 14. Oh, it skips that one. So after you get your points, draw a line of fit. Try to go through the middle. Arrows on it. All right. Then I want everybody to pick 2 different points. All of these are pretty close to each other. There's really no outliers here. So pick 2 points and find a slope. Not beside each other. I probably wouldn't pick like these, those 2 or even, this is a big difference. So when you get your slope, put your pencil down. So I can say who has a slope. So the rest of you keep working. Somebody tell me their slope. 5/2, so 2.5. Okay, what else? 2. What else? 9/5 is 1 point. How many days? So 1.4. What else? 1.75. What else? What else? See, on these scatter plots, it's okay if we get decimals for slopes because we're not really going to be graphing our line. Anybody else get a different slope? What is it? 5/9. Not even 1. Which 2 points did you use?
I used 1, 3, 6.
Right. We do it. I'll do those 2 because I haven't done one yet.
And I've got my line set 1, 3, 1.
Okay, I think it's gonna. Yeah, I think it's gonna be between 1 because 1 is right there, isn't it? So I think it would be between anywhere between 1 and 2 and 3. Right? Okay. So let me do a slope. I'm gonna do this one and this one. So remember my y's are on the bottom now, right? So I'm gonna have 12 minus 3 over 6 minus 1 is 9/5, and I'm gonna go ahead and just tell me what that decimal is. 9 divided by 5 is 1.8. Y minus y1 over x times x minus x1. This is the 0.13. Y minus y over x minus x. Like we've been. Yeah, that's wrong. That's why you got 5 nines. Okay, so 1.8. So all of our slopes are similar to each other, aren't they? Right? They're between like 1.5 and 2.5, right? Right? All positive, right? And what kind of correlation do we have? Positive. So if I write my equation that I'm getting y equals 1.8x plus 2. And like I said, your y-intercept, I would say, would be between 1 and 3. Right? Did y'all get something close? Everybody get something close? Okay. What do I want to do now? Okay. Let's not do this in the calculator. I'm going to pass back a worksheet. This is going to be your assignment for today. And we're going to do one in the calculators. Actually, we're going to do it by hand first. 3, 4. Yes, we are done with this lesson, but I'm going to keep the recording going because I'm going to show you how to do some fun stuff in the graphing calculator. So this is, I guess, we're going to do one of our homework problems, but this is still part of the lesson, I guess. All right. I want y'all to go, let's do number 7. Let's do number 7 just because it has fewer order pairs. So go ahead and graph those points, please, for number 7. I'm going to do it as well up here. What kind of correlation do you think this has? It's negative. It doesn't look too negative, but going left to right, it's up here and then it ends up down here, so it's negative. Draw yourself a line of fit through your points. And they gave us a B, didn't they? Yeah, this one's a B. So we can say B equals 1. So B is going to be close to 1. My line has it going more like a little bit closer to 2. So if you want to use that one, that's fine. But just for easiness, if they give you a 0 and then a number, that's probably going to be a good y-intercept. All right. So y'all pick 2 points and get a slope for me. 2. Tell me their slope. Okay. Anybody else? Okay. Anybody else got a different one? Okay. Those are all relatively close to each other. Now, your calculator can find the perfect slope for a perfect line of fit, and it's called the line of best fit. So what it does is it averages the distances between all of those points that are not touching the line, so that it is absolutely the most middle line that you can have between these points. So we're going to practice doing this on the calculator. So y'all bear with me while I get my calculator. Turn yours on. There's mine. Okay, turn it on. Right here, beside the arrow buttons is a stat button. Y'all see the stat button? Okay. You see above it in a different color says the word list. Right? Everybody should be doing this with their calculator with us, okay? I want you to hit second, which is your shift key. Anything you hit with your second key does the little same color stuff above a button. It's like a shift key on a computer, okay? So I want you to hit second, list. Sorry, that's not what I want. So hit second, quit. Second mode gets you back to home screen. I want you to go hit the stat. I want you to hit just the plain stat button. Okay. So hit the stat button and get this screen. And number 1 says edit. Okay, I want you to hit enter. And you should see a screen like this. Raise your hand if yours has numbers in it. Okay, so if yours has numbers, I want you to arrow up to where it says L1. That means list 1 is highlighted. And then I want you to hit clear. Clear is below the down arrow key. Hit clear. And then I want you to arrow over to L2. I think you might have to go down and then go over and then go back up. And highlight L2 and hit clear. Did that clear your list? Did it clear both lists? It should clear. No, I just need L1 and L2. All right, does anybody not have a clear L1 and L2? Let me come around and help everybody. Oh, yours is an L2. I don't know where your L1 is. Yeah, I don't know what to do. Grab one of mine. That's not a grab. I don't do cameos. I can't even do it. Grab one of mine. All right, y'all need to be quiet while I'm fixing everybody's. Grabbing this one. Now you got L1? Yes. Okay. All right, does everybody have an L1 and L2 and it's clear? Okay, so your L1 is going to be your X's and your L2 is going to be your Y's. Okay, so what you're going to do is for your X's, you're going to put them in order, 4, 3, 2, 1, 0. So arrow over to your highlighting under L1. I think you're going to have to if you hit enter, mine worked if I hit enter. and then arrow over to the L2 side and do your Y's. So I have, and when you do a negative, y'all, you have to use the little negative button down at the bottom by the enter. You can't use a minus sign. All right. If anybody needs assistance, let me know. L3, when you get to the third dimension, or if you're comparing two different, more than two lists. We don't need it. We just need X and Y. Yes. Yes, it's the same as this. It's your Y values. Okay. So, let me see. I think you can hit second, and then the Y equals button says stat plot above it. Hit that. And then hit enter, I think. Second Y equals, and then hit enter. And you want to turn this on. So arrow over and hit enter. And make sure it says L1 and L2 right here. And then you're going to hit the graph key. And you should see your points. If you don't see your points, let me know. Yes. I'm trying to do it up here. Right here. It won't after I'm explaining it and I have to go around and help everybody. But when you're doing it by yourself, you get quick at it. Hang on. Yes, and you get enter. You go to on, you get enter, and then you go to graph. All right. Who has that? Huh? Yeah. Anybody not have what I have on my screen? On where? Yes. All right, if yours is not working, look on with somebody's it is. Okay, so then I want you to hit stat again. Stat right there by the arrows. And then I want you to arrow over to where it says calc up there. And then you get a big list of things. Yes. And then I want you to hit number 4, which is linear regression. So you can arrow down to number 4, or you can type 4. And then I think you can hit enter. That's why I hate teaching calculators. What? Go down and calculate again. Mine's at 83, y'all's are 84. Cow. 4. No, I have an 84 too. Didn't do it. What's this on? Okay. So anyways, after you hit linear regression, you should see something like this. It says y equals ax plus b. And that it says ax plus b instead of a, we know that is also m, right? So it's saying negative 0.7 should be the slope. So are ours close to negative 0.7-ish? Some of them really are. And it says that the b is close to 1.2. And that's the perfect line. It's the line of best fit. I know. I don't know. I'm not good at, because everybody's calculator has different stuff stored in it, and I've got to. So this is not required. You doing it in the calculator is not required. It's just a good way to check. You gotta go down the calculator. Stack, count, forward. There you go. Yeah, the 84s make you hit calculate, then it should work. It just has extra stuff in it, that's okay. Do what? If you want to. Now, something else really cool. If you write down the slope, if you write down their slope they gave you, they said M was negative 0.7. And what did they say B was? 1.2. And then you go to Y equals. If you have it all cleared out. Now, if you've got junk in here, it's not going to work. But if it's all cleared out, and it says Y equals, and then you put in your MX plus B, so negative 0.7, and then the X is right here beside the alpha button, plus 1.2, and you hit graph, then it draws your line through your point. Yeah, and if you have a fancy one, it's in color. Mm-hmm. Hang on. And that is the end of the lesson today.